Hello guys, welcome to my video tutorial. In this specific tutorial, we will talk about Docker containers, how a container is created from an image, and how you can create an image to create your own Docker containers. Before I start the tutorial, I also write a blog at my site www.techieandtravel.com. Do check it out if you want to learn about technologies. And if you like my videos, please like, share, subscribe and comment it. Before you start this tutorial, I would suggest you to watch my earlier video on basics of virtualization and containerization. So let's start with the overview. Let's say you have an enterprise application stack where you host an Apache web server, you have a backend database, you have a Redis caching server to store and retrieve the data saved into the sessions, and you have some third-party integration. For many years, they are typically deployed on a bare metal, that is on an operating system that has complete control over the underlying hardware. Naturally, installing on a traditional approach made the software painfully difficult to move around and difficult to manage. So each application component, they have their own dependency and specific libraries, and also its dependencies to the operating system and the operating system versions. So managing it was really difficult. Take into consideration when you have to upgrade this piece of component, and then all the dependencies and libraries factor comes into play as well. And then it has to be re-evaluated if you want to upgrade any one component in the application stack. So this is painful and time consuming. So imagine when you have to do the same setup in the development environment, in your staging, and then in your production environment. It's time consuming and it's difficult to manage the components in an application stack, right? Hence, to facilitate and make application deployment easier and scalable, we have a concept called containerization, and we'll focus on Docker container in this tutorial. So you will have your same hardware infrastructure, you will have an operating system on top of it, but you will have a Docker installed on your operating system. And with this, you could package each of these components in your application stack in their own isolated environment called containers. Each container will have their own libraries and their dependencies, and all of them can run on the same host with the same operating system. So we only need to install Docker once on the host, and Docker provides this high-level tool with high functionalities for a user like us to manage each containers. So you don't have to worry about all the libraries, dependencies, the runtime issues like how to expose it in a network, how to manage its storage, memory, etc. And even how to control the access permissions, because all of them are handled outside of the application itself. And you'll get a consistency across all the containerized apps. So these Docker containers, they isolate a single application and all of its dependencies with the underlying operating system as well as from the other containers. You can run these Docker containers on any OS compatible hosts that has Docker runtime installed. So what actually is container? Container is a completely isolated environment, as in they can have their own process, they can have their own service, network interface, etc. Just like the virtual machines. Except the difference is that container shares the same OS kernel with the underlying host. So each Docker container built on top of the operating system, they shares the same OS kernel. Let's understand in brief about Linux distributions and the OS kernel they use. So if you look at the operating system, they all have two things: OS kernel itself and some set of softwares above it. Kernel is responsible for interacting with the underlying hardware. In all Linux distributions like Fedora, SUSE, Ubuntu, etc., while the OS kernel remains the same, it's the software component above it that makes the difference. This is what separates each Linux distros. So each of the Linux distributions, they have the same OS kernel, but the software components like user interface, file interface, networking, etc. is what makes it different. That's the reason when you log into each of these Linux distributions, you get a different user interface. That's why they are different Linux distributions, but they use the same OS kernel. Let's say you decide to use the Ubuntu operating system on a host machine. You install Docker on it. So if the underlying layer is Ubuntu, Docker can run any flavor of Linux based container. Like it can run Ubuntu, it can run Fedora, it can run SUSE, Debian, etc. But it won't be able to run the Windows container because, as I already told, containers share the same OS kernel with the host, and Linux kernel is completely different to the Windows kernel. Unlike hypervisor, Docker is just supposed to package containerized applications so that it makes it easier to ship them and run them as many times as we want. So let's discuss how VM and Docker container differs then. As you see, in case of Docker, we have a hardware, we have an operating system installed on a hardware, and then Docker installed on operating system. Docker manages the container that runs its own libraries and dependencies. In case of virtual machine though, we run a hypervisor like ESX on a hardware, and then we create virtual machines on top. The difference between virtual machines and container is that each virtual machine has its own operating system, its own libraries and dependencies, and applications. So because of this reason, VM is heavy and containers are lightweight. And then container boots up faster. On a VM, it needs to boot the operating system as well, so it's slow. Now that we know the difference between Docker and virtual machine, it's better to leverage the technologies behind virtualization and containerization in your infrastructure. By that, I mean if you have a hardware infrastructure, you can have a hypervisor like ESX to create multiple virtual machines. So each virtual machine can have their own operating system and then have Docker host installed on top of it, which facilitates to create the Docker containers. So you could create a Windows Docker container with Windows operating system installed inside a virtual machine. Let's look how we can create a container. Images are the core component of Docker containers. You can use an image to spin up multiple containers. Images are nothing but a read-only templates. They are built for a text file with all the definition about how you want your container to look like. And containers are running instances of these images. You can create your own Dockerfile and create an own image, or you can use the available images from the Docker registry called Docker Hub. There are a lot of applications that has already been Dockerized, but you can create your own image if you can't find the image that you are looking for. You can run a simple docker run command and create a container out of an image. It's that simple. Remember about the application stack we talked earlier? Now let's try to build the web server component of it with Apache installed. The first thing is to gather the steps that we normally do if we have to build the Apache server manually. So we first select the operating system. In our case, let's say we have an Ubuntu operating system, and then we update the Ubuntu packages. Then we install Apache and its utilities. Then we clean the unnecessary files from the system. We expose the web server port, and then finally we run the Apache service. So let's use this set of steps and create a Dockerfile. With Dockerfile, as I said, we define this set of instructions and the arguments. So the first step was to choose the Ubuntu OS. We define it with from command. The second step was to update the Ubuntu packages. We define it with run instructions. The third step was to install Apache and its utilities, and then subsequently clean the unnecessary files from the system. And then the step was to expose the web server port, which by default is an 80. and then finally execute a command to run Apache. Once done, you can build your image using a simple docker build command and specify Dockerfile as your input file. You can provide the tag name for the image. This will create an image locally on your system, but to make it available on a public registry, you have to run docker push command and specify the name of the image you just created. Now let's look at the Dockerfile. Dockerfile is a text file written in a specific format so that a Docker can understand. It's written in form of instruction and argument. In this Dockerfile, everything on the left in caps are instructions. These instructions instruct Docker to perform a specific action while creating an image. On the right are the argument. All Dockerfile starts with the from instruction. When the Docker builds an image, it builds it in a layered architecture. That means each line of instruction defined in the Docker file creates a new layer in the Docker image, with just the change from the previous. So as you see, here are 7 lines of instructions and arguments in the Docker file. Hence, it creates the 7 layer in the image. You can inspect an image after it is created to see each layer and their size. So because each instructions and arguments in the Docker file creates an image, it's ideal to keep your Docker file with as less instructions and arguments needed as possible. That will help you create the Docker image in a smaller size, and then subsequently it boots faster. So if you look at the Docker file, we can still modify this Docker file and create a smaller sized image. As you see in this example, we appended the run command instructions together. So the Docker file in this example consists of 5 layers, hence you have 5 layers in the Docker image. You can build your image executing docker build command with the -t as a tag name for the image. Docker builds all these layers in a cached system. That means if any step in the creation process fails, Docker uses the cached image layer from the previous build so that the build process is faster. So let's summarize. Every image is created from the Docker file, which has fixed set of instructions and arguments. You build the image with the help of docker build command. Then from the image, you run a container with docker run command. It's that simple. So final words, Docker Container Solution provides an easier, simpler, and faster way to build your application in an isolated environment so that you can do the repetitive tasks inside the container, you can destroy it whenever you want, and you can spin it as many times as you want in a scalable solution. Thank you for watching this tutorial. If you like my tutorial, please like, share, subscribe, and comment on the tutorial. If you want any specific topic to cover, please write down in the comment section and I'll try my best to present it in further videos. Thank you.